Oh, great. Salute to everybody. We have a possible equation that it is a bit marvelous, wonderful. The question is to compute the possible solution to the equation below. And our equation, yeah, tonight is given as y equals to e raised to the power x is equals to natural log of x. So if we look at this question, so many things comes into mind. We are looking for the possible solutions to these equations. So what may be the possible solutions to this equation? First of all, when we draw an asymptotic line here, let's draw our asymptotic line. Okay, it's not perfect, but then our curve will go this way. Okay, then the other one will be this way. No, I didn't get it right. Let me draw it well. Okay, so the other curve will go that way, this way, and that. So this equations. That's how we will represent them if we want to represent them in an equation form. Okay, beautiful. So what do we do in the first place? The equation given is y equals to e exponent is equals to natural log of x. Wow, it looks so beautiful. It looks so beautiful. Well, somebody will say, why don't you take natural log to both sides of the equation? Well, I will say no. We will see the reason why I'm saying that. See, in the first place, well, let's take e to both sides of the equation. Take um, e to both side of the equation. Okay, so we're going to take e to both sides of the equation. When we do that, we are going to get our e raised to the power ex equals to e natural log of x. Beautiful. Wow, isn't that it? That is how it is. So we know that this is equals to, x equals to e raised to the power natural log of x is equals to e raised to the power of x. All right. Now, if we look at the equation very well, we can see that x is once again equals to e raised to the power ex. As it goes on and on and on and on to infinitesimal, usually then we can say that x is equals to e raised to the power e, okay, to the power x, and as it keep going, so s can keep going on e to e to e to e to e to x, okay. Then eventually, maybe it goes to e raised to the power that dot to infinitesimal. Now, this it becomes a bit complex. As you can see, we are in a different world altogether. Okay, so but eventually, this implies that our e raised to the power x is equals to what? X. Some will say, why don't we take natural log to both sides again? But I say no. We can employ the Lambert W function. Okay, why am I saying that? Let's see. Okay, so let's divide both sides by e. So our equation now is going to be e raised to the power x over e raised to the power x. So you divide through by e raised to the power x. Okay, so we divide through by e raised to the power x. So this will be e raised to the power x is equals to x all over e raised to the power x. And eventually this will become 1. So we say 1 is equals to e x raised to the power e, which we can also write it as x, sorry, here is the power e negative x. Okay, so this implies that our equation 1 is equals to x e raised to the power negative x. Okay, then let's multiply by negative 1. You understand what I'm trying to say? So multiply through by through by negative 1. So that our equation now will become negative 1 is equals to negative x exponent negative x. Okay, so with this, we will say we should consider Lambert W function. Lambert W function. So we take Lambert W function to both sides. We're going to get W Lambert negative 1 is equals to, okay, that Lambert negative x e raised to the power negative x. Okay, so this, if you look at it very carefully, yeah, you will see that we are going to get x, okay, to be equals to negative 1. So this will say x is equals to negative w negative 1, okay, and that negative x. So that will be x equals to negative w x negative 1. Okay, so when we compute this with a calculator, the possible values of x that we're going to get will range from 0.318, 1.3334, and etc. I think this is how the best way we can go with this equation. So as you can see it, okay, first and foremost, the equation is given to x as y is equals to e raised to the power x natural log of y. Somebody will say, why? Dude, but you can do natural log. Yeah, yeah, fantastic. Okay, let's see. If we say we're going to do natural log, then our equation e raised to the power x is natural log of x. How do you do natural log with that? Are we going to take natural log to that, and natural log to that, the natural log of x. I think this will make the equation more, divisive or complicated way to be able to solve it. So the best method is to consider Lambert W function. Okay, so if you look at the equation very well, you see this is what we have, and then graphically that's how it will look like graphically. If we represent this graphically, that's how it will look like. Okay, so consider taking e, yes, e to the power x to both sides, yeah, taking e to the e raised to the power x to both sides of the equation. Our equation now becomes e, yeah, that's how it is. Then e to raise the power x, okay, sorry, so we take e to both sides, sorry, e to both sides of the equation. So then we have this e to e and that, okay, so this will become, yeah, e to e of that, yeah, so e to e of that. And our equation, if you look at it very carefully, so that we have e to e to ex, e to natural log x. Then we have our x goes to natural log of x. Oh, sorry, natural log of x. natural log of x, natural log of x. So this is natural log of x. Okay, this is natural log of x. This goes to e raised the power that. Okay, so with that we have our x, because we know that e to natural log of x will give us x. So that then we have our e to e exponent x. And if we consider it in this way, we see that as we go infinitesimally, we go high and high and high and high. Okay, eventually we see that e raised the power x is equals to x over here. Then we divided both sides by e raised the power x. Okay, then we achieve this equation. Okay, then we know that divisively e raised the power x over e raised the power x will give us 1. Then x over e raised the power x, this can be written this way because when we transpose the x here, our equation becomes x raised the power negative x. Okay, now knowing that 1 is close to this, to be able to compute it, we should multiply by negative 1, multiply through by negative 1. So we have negative 1 and negative x raised to the power negative x. Then we consider Lambert W function. Okay, Lambert W function. Then we have w negative 1. Okay, is equals to w this function minus x raised to the power negative x. And as we compute that, this one will give a negative 1, and that will give us x. So therefore we say x is equals to negative w negative 1. Okay, then the possible values are 0.318, and so we can try it on the calculator and see so that we are within the values. So thank you very much for your coming tonight. Okay, as you can see, we are able to break this equation down. Well, as I always say, please subscribe to this, yeah, so that will give us more strength and energy to be able to do more. Well, as I said, there's a discussion, and you have every right to access anything you want us to do. If you have a question and it's a bit complicated and maybe you think we can work it together, you can send along. But subscribe and also share and like the videos so that we can do more. Thank you, and have a beautiful evening.